Hello everyone, my name is Abhishek and welcome back to my channel. So I'm getting a lot of requests on LinkedIn as well as on my YouTube comments to make videos on Kubernetes troubleshooting, like what are the problems that we run into Kubernetes in production and how do we, how do we solve them? What are the issues with respect to pods? What happens? How do we debug when some pods are down? All of these things. So I thought I'll make a complete series on the Kubernetes troubleshooting because practically it cannot be made in a single video. It requires a lot of effort from my side as well, you know, to set up Kubernetes clusters at that level and, to debug each, like whenever I have to explain you a specific scenario, I have to create that scenario and I have to explain that. So it even consumes a lot of my time. So I thought I'll make this in episodes, but given a condition that uh, please comment on the video, like once you watch this video, let me know that are you interested in the future videos or not, or do you want me to continue this series or not. Like I told you, because it takes a lot of effort from my side, so I would be very keen to hear feedback from you and only then proceed with the next episodes of this series. Okay, so now without wasting any time, so the topic for today, as I told you, is troubleshooting common Kubernetes problems. So yeah, this is a very common scenarios, right? Whenever you're running your Kubernetes clusters, for sure you'll run into problems in your production environment because everything will not go smooth. That is for sure. So what you have to do when you run into problems and what are the commands that you have to look at, or we'll also take a look at what are some of the common scenarios. So this is the topic for today, common Kubernetes problems, and you can also use this as a handbook. So once we complete the entire series, you can use these videos as your reference purpose as well, and we will do it in a lot of episodes as I mentioned. Okay, so now to start with, firstly, we will take a look at what are the different scenarios that we run with respect to pod. Okay, so we'll start with pod, but eventually we'll look into the common scenarios with respect to services. We'll look into common scenarios with respect to ingress, why your cluster is not responsive, issues with the nodes and Kubernetes control plane, how to set up Kubernetes in high availability, what are the problems with high availability. So all of these things we'll try to cover as episode number one. As this is episode number one, we'll start with pods. So what are some of the common scenarios that you look into issues with the pods, right? You have image pullback off. You have whenever you're expecting your pod, but you see when you do kubectl get pods, you see errors like image pullback off. You see errors like error image pull, registry unavailable. Crash loop back off is one of the common things, and kill container. Apart from this, like these are some of the common scenarios, but apart from this, you might have also noticed that you don't run into any of these things, but your pod is not coming up, right? So what can be the reasons? Okay, we'll also look into that. Like I have provided enough details for each and every solution as well. So we'll go step by step. But before to that, I would like to tell you that whenever you are trying to debug any Kubernetes resource, whether it's pods, whether it's deployment, whether it's let's say ingress, service, admission controllers, or anything, whatever you are trying to debug on Kubernetes, first thing is you need to understand the API reference, right? How is this Kubernetes API defined, and what are the different fields or what are the different objects that are involved in this API? Okay, to understand that, Kubernetes has a wonderful documentation for its API reference. So what you have to do is just go to Google and search for Kubernetes API reference docs. And once you land, once you click on that, you land on this page, and then you can select the object that you want. Okay, so I'll show you how important this is for everybody to understand, because now I selected pod and you see everything with respect to pod. What are the fields that go into pod? You have pod's API version, kind, metadata, and you have pod spec. So pod spec has all the fields that go into pods. And whenever you look into, let's say you are working on your Kubernetes cluster, and you just joined an organization. Let's say you're new to Kubernetes and you don't understand a specific field. What is that specific field doing? Okay, so rather than you go to Stack Overflow, Medium, or GitHub or any sources and search for its definition and understand only half of it, you can actually come here. Let's say in your pod.yaml, you found out that you are using ephemeral, right? Ephemeral container. So what is an ephemeral container? So you can definitely find it in Google, but when you come to the API reference, you have, this is like a one-stop handbook for you. And everybody should spend some time in reading through the API reference docs, because Kubernetes maintainers maintain this pretty well. And if you want to learn about ephemeral containers, so you can just read through this and understand, okay, so this is ephemeral container, and you might be using only specific objects in your pod. Like, pod API reference has a lot of objects, but you might only use few things like command, you might use image, you might use volumes, or all of these things. But what if you are not aware of what is init containers, you are not aware of what is ephemeral containers, right? So let's say you are new to init containers. You can read through this and understand, okay, init containers are something that actually runs before your actual container. Okay. And let's say you are new to the concept called node selector. I'm just giving these as examples. So first thing is, whenever you are learning any specific thing in Kubernetes, so in our video, in the current video, we are debugging Kubernetes pods. So to debug and to understand, right? Just watching this video will not help you in any ways, right? You must initially have a basic understanding. Either you follow my previous videos on Kubernetes pods deployments, or the other thing that you can do is, definitely whenever somebody is making a video, will not cover all of these objects, right? Anybody will not cover all the objects. So the first thing that you need to do is, you need to come here and you need to read through the pod spec, or if you are trying to learn daemon sets, right? So what you need to do is come here and go through the daemon set spec. So you have different how do I say, you have different objects, and you have explanation for each of these objects and what are these objects doing. So this is step number one. And the step number two is, let's say you found out that, okay, your controller is in crash loop back off. Okay, so what are the things that you have to do? So that is what I'm going to explain now. And what I'll do is, meanwhile, I'll create a Kubernetes cluster. Okay, so that we can actually try out these scenarios, and I will show you how to debug these things as well. So like I told you in my previous videos, I prefer using kind. So if anybody is new to kind is nothing but Kubernetes and Docker. So people use Minikube, people use K3s, K3D, kind, micro, K8s, lot of Kubernetes distributions. But personally, I prefer kind. The reasons are, kind is pretty fast when you're using for your development purposes. Minikube, coming to Minikube, it might be slow at times, because Minikube requires almost 2 to 3 CPUs, and sometimes 4 to 8 GB of memory. But kind is not like that. Kind is specifically designed to run your Kubernetes cluster inside a Docker container. So that's the reason why kind is pretty light in weight, and you can easily spin up 15, 20, or any number of Kubernetes clusters on your local, like when you are trying to test with multi Kubernetes cluster environments. So kind is one of the better things to use. And if you want to learn more about the differences, what is the difference between kind, Minikube, micro, K8s, I've already made videos like which is the best, or which is the better Kubernetes distribution. So just take a look at that video for your understanding. But I prefer kind. So kind also has a very cool interactive command line. So I can simply search for kind get clusters. I don't have any cluster. What I'll do is kind create cluster hyphen hyphen name. Let's call it K8 troubleshooting, something like that. Okay, and what happened is, your kind cluster is getting prepared, and since I have not mentioned anything about the nodes, it just prepares with a single node. But just to let you know that with kind you can also create multiple node Kubernetes cluster, and you can vary like how many number of master nodes you want, how many number of worker nodes you want. Let's say I want to create a Kubernetes cluster with 7 nodes, 4 masters, 3 masters and 4 workers. You can also do that with kind. Okay, so just to tell you that you can create a high available Kubernetes environment with kind. Okay, so while this is getting created, let's go back. Okay, so now going back, what are the common errors that we get? So to start with the basics, the first error that you would see is image pull back off. So what happens most of the times is that, or when you are a beginner, is you try to deploy your Kubernetes deployment. So mostly people don't deploy pod directly. So people either go with deployment, stateful sets, or daemon sets. So let's say you're using a deployment to deploy your Kubernetes pod, and you don't have a correct information of your image, right? Or you got wrong information about your image name or image tag, or you don't have permissions to the image itself. Let's say I put this image in quay.io, or I put this image inside a private Docker registry, I mean private Docker repository, or any private container registries. So what happens is you run into the image pool backoff. So what are the three major issues? One, it can be invalid image, it can be invalid tag, or invalid permissions. So how do you find out these things? Okay. So the first thing is, let me create a Kubernetes deployment. Okay. kubectl create deploy, name is equals to nginx hyphen hyphen image is equals to nginx. Okay, sorry, the syntax is slightly wrong. Yeah, so this creates a Kubernetes deployment, right? Now, if I do kubectl get pods, what happens is my Kubernetes pod is getting created. The container is running, right? So this is getting created and it will eventually run because you have provided exact information, like what is your image. Like if you go back, if you try to remember the command that I've executed, what did I do? kubectl create deploy, name is equals to nginx. Okay, sorry, name is nginx and hyphen hyphen image is nginx. So what I'm trying to do is, here I'm trying to pull the Docker image with name called nginx. Okay, so it exists in the Docker hub, so it will be eventually pulled. It is taking slightly longer time than I expected. Okay, no worries. Now, what if I provide information like kubectl create deploy hyphen hyphen image is equals to nginx1 or nginx not available? So what happens is, instead of your container getting created, you will run into the error like image pull back off. So this is the reason. And how do you debug this information? You can simply say kubectl, okay, describe deploy nginx, or you can get the pod name kubectl get pods. Okay, once you get the pod information, so if you see the pod is currently running, so once you get the pod information, what you can do is kubectl describe. Okay, and here you have the information that image is pulled successfully, pulling image nginx, successfully pulled image. So that means your image is successfully pulled, and that's why your Docker container or your uh, Kubernetes pod is running successfully. Now, what happens if I come here and say kubectl edit deploy nginx? Oh, sorry, the name I gave it as nginx. Okay, my bad. Nevertheless, what happens if I come here and if I modify this from nginx to nginx does not exist? Okay, I'm just giving a vague name. And if I save this, now what happens is, just do kubectl get pods and try to watch for this. Okay, here the previous container is still running because Kubernetes deployment follows the rollout strategy. So what happens is, this is getting rolled out. The replica set, new replica set is getting created, and it's rolling out a new container. While this is getting created, the existing one still keeps running, right? So kubectl get pods. Okay, so this is taking some time, but what happens, I'll show you, is that this image will run into image pull back off. This is the first error. Now you might ask me that what if I don't know the commands? Okay, so Kubernetes provides, again, there is something called kubectl cheat sheet. Okay, so I'll put all of these links in the description. So in this kubectl cheat list, this is the best troubleshooting guide that one can look at. Okay, so like you can take a notes of this video, but you can simply bookmark this page, kubectl cheat sheet, and you have all of the commands that you want here. Like, this is specifically designed for the purpose of debugging and troubleshooting. Okay, so let's say you want to look into the Kubernetes nodes, anything related to nodes. So you can simply come here and look for nodes. Okay, you have all the commands with respect to nodes. Or you want to look at, let's take an example of rollouts. Okay, so So you have commands with respect to rollouts. So these are some of the common commands or most used commands during the Kubernetes troubleshooting. You also have the index information here. So how do you patch a resource or how do you edit a resource? Let's say I edited a resource called deployment right now, right? So if you want to look at the editing of resource, you can come here. If you want to scale up, scale down. So all the things like deletion, all the commands are available here. So you can use this as a troubleshooting guide. Now see, we ran into the error called image pull back off. Okay, so let's see what happened is this is the error called image pull back off. Okay, so this is your first example. Then once you learn about image pull back off, the next thing is, okay, so image pull back off is something that you already understood. You have given a wrong image or you have given a wrong tag or you have given invalid permissions. But what if everything is correct? Okay, my image information is correct and everything looks good, but still my application is not running. Okay, so the reason, possible reason could be, whenever you're running in a production Kubernetes environment, what your Kubernetes administrator does is he will allocate resource quota for each and every namespace. So now what is resource quota? Let's try to understand that. Let's say you have a Kubernetes cluster, okay? And in this Kubernetes cluster, if there is only one team that is using this Kubernetes cluster, that is totally fine, right? You can use or you can enjoy the complete resources of this cluster. Let's say it has 10 GB memory, just for an example, okay? Or it has 100 GB memory. So you are the one who can use the entire memory of it. But what if you are using this Kubernetes cluster in your corporate setup, and your Kubernetes cluster is used by 5 teams? Okay, so now all of these 5 teams have to use the resources of the Kubernetes cluster. So what this administrator does is he will allocate the resources depending upon your requirement. So let's say there is a team called XYZ and XYZ requires more resources, and then there is a team called X requires only less amount of resources. So depending upon the kind of application, kind of environment that you're working on, uh, so the administrator assigns resources for you. Now, what happens is whenever you are creating a Kubernetes pod, you have to definitely create Kubernetes pod with the resources specifically. Like if you are not providing, okay, so I'll show you this with an example. Let me create a Kubernetes. Let's say that the kind cluster that we have just created is a production Kubernetes cluster. And in this production Kubernetes cluster, there are XYZ, like let's say that there are 5 to 6 teams. And now this is a namespace that is created for a team called payments. Okay, so what I'll do is kubectl create namespace called payments. Now the team members of payments will use this namespace and they'll not have access to the other namespaces, right? Because in Kubernetes, how do you do the logical separation? Logical separation is taken care by the namespaces. Like if you have a deployment and I have a deployment, or I cannot access your resources, you cannot access my resources. So the Kubernetes RBAC typically depends upon namespaces. Okay, so what I've done is I've created a namespace called payments. Now what I'll do is, as a Kubernetes let's say I'm a Kubernetes administrator, and as a Kubernetes administrator, like I told you, I will allocate a specific resource quota for this namespace. Okay, so how do I do that? I can simply come here, and what I can say is, so if you see here, the resource quota name is present. What I can simply do, okay, I would like to edit this one here. Okay, let me copy this and take this into a notepad. Sorry for that. Okay, so I have a notepad here, and what I'll try to do is I will try to apply the resource quota for this specific namespace. So how do I do that? So this is the resource quota resource. I simply copied it from the Kubernetes documentation. And what I'll do at the end of this command is, okay, I can do it through the command line as well. Just I'll copy this resource quota completely. Or, okay, let's say, let me simply execute this one. Resource quota .yaml. Okay, so this is the resource quota I have saved, and let's say I want to assign this resource quota to the namespace that I've just created. So kubectl apply -f resource quota.yaml -n payments. So now this payments namespace will be associated with this specific resource quota. So what is defined in the resource quota? If you go back here, so this resource quota says that the hard limit, okay, hard means that the hard limit for this complete namespace is only one CPU and one memory. Okay, so this is the request, and the hard quota for the limits is 2. I mean, the minimum is 1. I mean, whatever people can request is 1 GB, and the maximum defines the limit. So limits is only 2 GB. Okay, let's say the user wants to create 4 pods. Okay, so they have to look at this resource quota. They have to look at the requests and limits, and they have to configure their pods according to the resource quota requests and limits. Okay, now that we have assigned, now what I'll try to do is kubectl create deploy. I'll use the same command. Okay, kubectl create deploy nginx hyphen image is equals to nginx. Okay, last time this command worked. If you remember, when I used this command exactly on the default namespace, everything worked fine. Now I'll use the same command but on the namespace called payments. Okay, so if you are new to Kubernetes, what you will think is, okay, the command is correct and the namespace also have provided the information, but you are not aware that the admin has configured this namespace with the resource quota. Okay, so in such cases, what happens is kubectl get pods -n payments. Okay, no resource found in the payments namespace. Okay, but I have just created a deployment, so deployment should roll out a pod. What has happened? So if you see here clearly, your deployment is created, but there is no pod in the ready status. Even if you see, there is no up to date, there is no available pod, but you have executed the command. So what is going wrong? How do you understand? Okay, now that I have explained you that there is a resource quota and everybody should provide, or you should create the pod with resources and limits. But how do you debug this information? So similarly, come here and say kubectl describe deploy nginx -n payments. Okay, when you do this, you will notice that you have created your deployment, but what is happening is your deployment is not able to create. Okay, if you look at the error here, you have the information that failed to create. Okay, now why it failed to create? How do I understand this information? So we'll come to the next important aspect, that is kubectl events. Okay, so what happens is whenever you are doing anything on Kubernetes, okay, so Kubernetes creates events for you. So what happens is, let's say your pod has to be created, but it's not getting created for some reasons. So what you have to do is you have to look for the events. So firstly, you will go to the kubectl describe. If you find anything in the describe, okay, well and good. Or else you can go to the kubectl logs. Okay, to understand, okay, your application is going into crash loop backoff. We haven't come to crash loop backoff yet, but let's say that your application or pod is going to crash loop backoff. So in such cases, what you can do is you can either look into the logs or describe. But if everything is correct, okay, your application is not going into crash loop back off, your image is not pulled back off, but still your application is not running, so your last resort can be kubectl get events. Okay, so if you're not aware of the kubectl get events command, you can read about the kubectl get events command, and if you don't know the syntax, like I told you, you can always copy it from your kubectl cheat sheet. Okay, here you will find the information why you are like previously this is not existent, the events are not recorded yet for the pod, but if you come to the events, you find everything related to your how do I tell how do I say everything related to your pods information, or everything related, whether your node information, or here it has node has sufficient memory. Okay, everything related to your Kubernetes. So this is the information that you can get from here. Now if you move to the next topic, that is crash loop backoff. So now what is crash loop backoff and how do you handle crash loop backoffs? So crash loop backoff is nothing but your image is pulled successfully. Okay, your image is also running successfully. Let's say you don't have any restrictions with respect to resource quota, or your image is pulled back, your image is pulled successfully. But still, after your image is pulled and after your container is created, during the runtime, what is runtime? When your pod is actually getting executed, you have noticed that your pod is not running and your container, it got created, but immediately it ran into the error state and then it ran into the crash loop back off. So if you see here, kubectl get pods. Previously, we created Nginx image, the first one, and that is running perfectly fine. Now, what I'll do is, as a developer, what I've done is, this is a Docker file that I've written. Okay, so I'm using the same Nginx image. Okay, and what I did is I wrote a script called test.sh and I switched back to the user called 1001. It can be any user. Now I'm executing this script. So what does this Docker file functionality is? It will basically create the container, and during the runtime, you have provided the command, or you have provided the entry point. So using this command or entry point, I mean, you can also provide entry point, or you can use command. So basically, with with command or entry point during the runtime, these commands get executed. Now, what is in the command? If you go to test.sh, so I'm trying to write onto the etc file, etc folder. But if you go back to the Docker file and see, the user which it is trying to do is 1001. So it is not a root user. And if you have knowledge with respect to Linux, you should understand that nobody can directly write to the etc folder except for the root user. So in this case, what happens is, if I create this image and if I apply this image to the same deployment.yaml file, you will run into crash loop backoff. Okay, so what is crash loop backoff? Crash loop backoff is an error which comes during the runtime. And what is the reason for the crash loop backoff? Crash loop backoff occurs when your runtime configuration is not working. So let's say you have a Python application and your Python application uh, is working superly fine, but it is trying to write to a folder and that folder does not exist, or it is trying to write to a folder where it does not have permissions to. So your application gets executed, but eventually your application will go to crash loop backoff, or your application will run with an error. So your container will get stopped if there is a panic inside your application logic, and your container will go to crash loop backoff, and eventually you will see that the deployment has 0 pods. I mean, 1 pod is there, but it is running with crash loop backoff. So this is the thing with crash loop backoff. And if you are reading more about crash loop backoffs, you should also understanding about I mean, you should also understand about liveness probes. So even if there is a liveness probe failure, you will run into crash loop backoff. What is liveness probe? I have described in my previous videos, but just for a reference, liveness probe is nothing but, uh, whenever you want to know your application, like whenever you're doing production scenarios, you define your pod with both liveness probe as well as readiness probe. And this liveness probe is basically used to understand that your application is live, and readiness probe is used to understand that your application is ready to accept the traffic. So just you deploy your container and you cannot say that, okay, send me the request. It will not work, right? Your application will take its sweet own time, and let's say your application has to start, it has to pull some configuration from config map. Your application should start a process, or your routines, or your thread should start. Only then you can start with accepting the traffic. So for this, you have both liveness probes and readiness probes in Kubernetes. And if even if you run into failures with this, you will run into crash loop backoff. And finally, you have other errors like node does not have sufficient memory. This is also possible case, right? So nodes might not have sufficient amount of memory, or you have admission controller which is blocking this one. So what is an admission controller? Admission controller is something which takes place after your authentication. So first let's say that you are deploying something into your Kubernetes cluster. The best example is Istio. Okay, so what happens when you have the Istio configuration? Whenever you deploy a pod, there is a sidecar container that gets created inside your pod. And how this is happening is because of your admission controller is using a uh, mutating webhook. And using this mutating webhook, it updates the configuration of the Kubernetes pod. It creates one more container. So similarly, your organization or your admins might create admission controllers to validate something with respect to your pods. Let's say that they only accept a pod if it gets deployed on node X, or they'll say that only deploy your pods on node X or XY or XYZ or something like that. So they can configure this in your validating webhook. And if your pod configuration is not reflecting the same, your pod will still again run into errors like not ready, or cannot be deployed, not available. So all of these things. So these are some things, and like I told you, these videos take a lot of time. So if you like these videos, please do comment so I can go into the complex topics. Like I just mentioned that about the validating webhook. So if I have to create a cluster and create the configuration for validating webhook, so please let me know that please show your interest on these videos. Only then I can move to the next episodes. And like I told in this video, please focus on the Kubernetes cheat sheet and the API reference documentation. That will help you to become a very good Kubernetes engineer. Uh, and yeah, I think so. This is for today's topics where we have covered about the basic scenarios of pods troubleshooting. If you want to learn about the advanced pod troubleshooting, and then we have to move to the service and ingress level debugging and troubleshooting. So yeah, please comment on this video, like this video, share this video with the friends who are willing to learn about Kubernetes debugging and troubleshooting. Yeah, I hope you found this video useful, and I'll see you in the next video. Thanks a lot. Take care. Bye.